Okay, Kelly, so I'm going to explain to you how to find the determinant of a matrix that's larger than 3 by 3. 2 by 2s were easy, 3 by 3s were a little harder, but still pretty easy. We just broke it down into some 2 by 2s. 4 by 4s are going to take a little bit more time, and know that your calculator can do this for you if you're interested in doing it. I'm sure when you look in that, first you would enter the matrix, right? And then you would go into that screen where you can tell it to do different things to your matrix, and it should have something that says find the determinant. But I still will show you how to do this by hand. So it is similar to your 3 by 3 in that you will break it down into smaller matrices, but it's a little more involved because, of course, since it's a 4 by 4, you break it down into 3 by 3s. So then the 3 by 3s end up, being 3 by 3s that we have to find the determinant of too. So anyway, when you decide how to expand it, you have flexibility on what row or column you use. I know when I went over this the first time, we basically stuck it out with that first column just because we were doing 3 by 3s. They were pretty small. It wasn't a big deal. But now that you're in your 4 by 4s, you kind of want to be choosy, I guess is the best word, with what row or column you expand it by. You want to choose one that has a lot of zeros in it, because when you expand it, those zeros are going to be kind of important in that they don't really require us to expand it much because you would be doing 0 times something. So when you're examining your 4 by 4, know that you can expand any row or column. So if you're looking at your matrix and you'll go, there's a lot of zeros in that row, or there's a lot of zeros in that column, that's the one you will choose, okay? So I look and I say, oh, there's a lot of zeros here. I'm going to expand along that row, or that column, excuse me. So expanding it is going to be where we will break off any of our non-zeros, and we will then leave behind whatever 3 by 3 is left if we remove his row and his column. So with that said, this leaves behind the -2, the 4, and the 1, the 5, the 0, the 5, the 4, the 0, the -1. Another difference, so this is kind of familiar so far, right? You pick a number, you break it off, you tell me what's left behind. That's what we did. Let me scoot it up so you can see. Then what we would do in this, that is an addition from your 3 by 3s, is you multiply by -1. You're going to raise it to a power, specifically the power that is his row and his column. In other words, that 2 is in the first row and the second column. So you're going to raise it to the power of 1 plus 2 here. Trying to keep this lined up so that I'm not holding it with one hand. I haven't set it on a stack of books. Anyway, so I am going to work with what's in front of this first so that I can at least break that down into one number. So this is -1 to the third power times 2. Well, -1 raised to any sort of odd power is going to be -1. -1 times 2 is -2. So I know I've got -2 in front. Let me scoop this down and this up. Maybe that'll help me. I've got -2, and I'm still finding the determinant of this 3 by 3 here. Okay, so again, you have flexibility when you go to expand this one. Remember that to find the determinant of a 3 by 3, we broke it down into 2 by 2s, basically. We stuck it with the first column every time and just broke it off, number by number, put in the -2 in front, the 5 in front, the 4 in front. But again, you can be choosy with which row or column you expand it by. So if you see a lot of zeros, roll with it, like tons of zeros. I'm going to expand by that second column, okay? So what I'm going to do here is I'm going to keep my -2 out here. Then I'm going to pull my 4 off, okay? And I'm going to, of course, delete his row and his column and find out I'm left with a 5, a 5, a 4, and a -1. So because he's the only non-zero in that entire column, I don't have a whole lot more expanding that I need to do because, 0 times anything, 0. So that helps us tremendously if we can find a row or column with a lot of zeros. So when I go to find this, of course, we're real familiar with how to find the determinant of a 2 by 2. You're going to do that right there, okay? So you've got your -2, and then we're going to do 4 times, because this process here is how we find the determinant of our 2 by 2, right? Let me scoot it up. So 5 times -1 is -5 minus 4 times 5, which is 20. So -2 times 4 times -25. -25 times 4 is -100. And then you should do -100 times, I just need to scoot it down, -100 times -2, and negative times a negative should be a positive right there. So we end up getting a determinant of 200 for that, okay? So that's your final answer.